The most common calls for support we get relate to electrical noise in installations. Electrical noise is a painful problem. It's difficult to predict when it's going to happen, it's difficult to measure when it does happen, and it's difficult to explain it to your customers. Getting called back to site to fix an incorrect load display or a glitching load limit is expensive, and it's stressful too. The good news is we've fixed the problem. We've taken our load cells into the digital domain, and in this video I'll be showing you our D-Cell product. So the root cause of electrical noise problems on cranes are the way the load signals are moved around on a crane. These load signals are tiny. We're talking millivolts and milliamps. And these signals might run 2 to 20 meters down a length of cable that is only a few millimeters away from other cables that are carrying hundreds of volts and hundreds of amps. It only takes a tiny amount of energy to be coupled from these high voltage, high current cables into the low voltage, low current signal cables. And if that happens, your signal's swamped and unusable. With our new D-Cell system, you get rock solid signals every time, with no screen cables, no earthing clamps, no careful routing, and no sensor noise. To understand why this works, these tiny signals, they still exist. The sensor still makes these tiny signals, but they travel less than an inch to a smart piece of electronics that's embedded inside the load cell. This electronics turns that tiny signal into a digital signal, and then sends that signal digitally down the same length of cable, the same kind of cable even, back to the electronics. This digital signal is uncorruptible by electrical noise. To give you a bit of a demonstration of just how solid this D-Cell system is, here are two cranes that we've wired up. The one on the left has the old analog system fitted, and the one on the right is wired up with a D-Cell. When we turn them on, you can see the little glitches and spikes and wavering loads. From the analog system, this is caused by the noise. If you look at the one on the right, that signal is rock solid. To really demonstrate just how durable and robust this system is, let's test it under the worst case scenario. Here we have Doug, who's going to TIG weld on this unearthed piece of metal, running kilovolts of interference through the sensors. Even with these thousands of volts though, we can see the same results. The analog system is jumping around all over the place and misreading as these huge voltage spikes affect it. Whereas the digital signals don't change at all. It's rock solid. And this is because the D-Cell is continuing to move this data back digitally into the load display, and that digital signal is unaffected by even this much interference. So if your customer is half an hour away and you have to revisit to sort out an electrical problem, you've got an hour of travel time, you've got an hour to 2.5 hours on the crane, so you can easily run up 5 or 6 hours worth of labor cost, plus an unhappy customer if you don't get your load cell installs right the first time. D-Cells are now standard issue with all of our products. So if you order a lift log, a max out, or a HiBeam 200 load display with a load cell bundle, you'll get a D-Cell and your install will be right the first time. So if what you want to do is to drive down the risk, drive down the complexity of your installs and get it right first time, take a look at our products or give us a call and we'll work through the problem with you.